Welcome everyone to today's meetup entitled Navigating HIPAA in a Geospatial World. I'm Esri Garrity and I'm the Chief Medical Officer and Health Solutions Director at Esri. We're really delighted that you chose to join us today for this important topic. I do want to be clear at the outset that this meetup is about sharing information and helpful tools with you, but it shouldn't be considered legal advice. That said, I have checked the content of this presentation with a privacy lawyer to ensure its accuracy. You should also know that this webinar will be recorded, and you'll receive an email in a few days giving you access to that on-demand recording. So here is our agenda. I'm going to kick us off with some background about HIPAA and its relationship to geography. Then I'll turn it over to Dan Exley, the Senior Vice President and Chief Client Officer of our business partner, Spatialytics. Dan has been an informatics leader for more than 20 years, creating positive impact for health organizations. Now he's going to talk about the very foundations of using geography as he discusses safe geocoding in the cloud. And lastly, you'll hear from Lucas Green, Program Director at our business partner, GIS Inc. Lucas also has 20 years experience with a focus on safety and risk management for the Department of Defense. He's the product manager for the development of MapMask, a tool that makes geomasking and aggregation really easy. We expect we'll have about 10 minutes at the end for your questions. And by the way, please use the question box in the GoToWebinar interface to post your questions at any time during the meetup. So here's the big issue, or the crux of the matter. Health leaders and organizations are recognizing that a person's zip code is a more important predictor of their health and longevity than their genetic code. And of course, it's not just zip codes that we want to analyze and use, it's all kinds of geographic data. In fact, one measure of the quality of the data that you use for any analysis is the level of geographic granularity that you have available in your dataset. It's well known that larger areas of aggregated data, like states or counties, tend to mask disparities that may exist within a community, which could ultimately handicap your ability to inform policy creation, plan and prioritize your interventions, strategically target your efforts, and evaluate your outcomes for the desired impact. So it appears we have a conundrum, because as we apply techniques to anonymize data, we will inevitably lose the detail in the data. I thought a gentleman by the name of Paul Ohm said it very well. Data can either be useful or perfectly anonymous, but never both. In other words, these two concepts are mutually exclusive.
Esri?
Well, yes.
Sorry to interrupt. Are you moving your slides forward? It appears we're still on the first slide.
Really?
Yes.
I am, and my screen is showing the slides that I'm on. What do we suggest I do?
Exit out of your PowerPoint mode and let's bring it back up again. Sorry, everybody on the call.
Okay.
Thank you, audience. I appreciate you letting me know you're also seeing the first slide.
Tell me if you are seeing a HIPAA requirements slide.
We are not.
Okay. Oh, I am the presenter. I'm going to check my screen again.
Here we go.
Oh, okay.
We're
so
there.
Now you're seeing it? Okay.
Yep.
Very good. So sorry about that. You didn't miss too much except for the very handsome pictures of Dan and Lucas. So I will continue with the story and now with the visuals. Thanks everyone for being patient. But my point is that we can solve for the conundrum that is posed between getting useful data and anonymized data. So I'm going to spend a few minutes reviewing the law, and then I'll talk about methods to de-identify data while still keeping it useful. Okay, so HIPAA stands for the Health Insurance Portability and Accountability Act, and this became law in 1996. And while the Act does have several different parts to it, our focus for this conversation is the Privacy Rule, which deals with the protection of individual-level health data. And I've just changed slides, so if it didn't change, please let me know. We call the data Protected Health Information, or PHI. The definition of PHI is any individually identifiable information that is created, used, disclosed, or received by specific types of health organizations. Now, I really like the simple graphic that's shown here because I think it makes it pretty easy to determine if a dataset has PHI. So in order to be considered PHI, it must include both identifier information about a person as well as health-specific information. And of course, one very important identifier is a person's address. In fact, location is a critical variable that bad actors or malicious people use for successful re-identification attacks and resulting privacy breach. Our goal then is to create some kind of a barrier so that bad actors out there in the world aren't able to use the results of your work, whether it's a map, a table, an infographic, or some other information, to reconnect those two components of PHI and thus identify an individual. So who exactly has to worry about the HIPAA Privacy Rule? Well, organizations that need to comply with this law are called covered entities, and they include health plans, healthcare providers, and healthcare clearinghouses, which are companies that may have access to protected health information in the billing or the claim services that they provide. Now, I think it's worth noting that while researchers are not covered entities by themselves, they are subject to the same requirements if they gain access to PHI. And that could be either through their employment or maybe through an institutional review board process where they received data from a covered entity. So the responsibility for protecting the PHI transfers in that case with the data. Now, since we're going to be focused on the location part of your data, you need to think about that foundational process of geocoding. Geocoding is the process of connecting an address to an actual place on Earth, and it's often expressed as a latitude and a longitude. Now, I want to strongly urge you to take care when geocoding PHI. My next two slides are going to give you some do's and don'ts on geocoding, but you should also know that your geocoding method could unintentionally obfuscate your data. So in other words, if you don't have high quality geocoding, your locations may not be accurate to begin with. Now, two things that are really important for getting quality geocoding results. First, you need good reference data, and that's the underlying road network and associated information that you can get with the Esri World Geocoder or the StreetMap Premium product that's created by our business partner here. The second thing to remember is that you need to ensure that your matching rules for the geocode are properly adjusted. So in other words, determine if a 90% address match is needed for your data, or perhaps 80% is going to do just fine. Okay, well, let's start with some of the things that you should not do when geocoding your data. Please do not give your data to someone else to geocode unless you have a special kind of arrangement with them, like they have IRB permission to work with your data, or maybe you have a business associates agreement or BAA with them. Now, in case you don't know what a BAA does, it basically extends HIPAA responsibilities to the signatory of the agreement. Also, as you consider the ways that you can geocode using Esri products, please be aware that you cannot geocode PHI in ArcGIS Online unless you have it deployed in a private cloud environment. Now, here's what you can do in your geocoding process. You can geocode PHI on your desktop within your organizational firewalls if you have the reference data on your desktop computer as well. Likewise, you can geocode in your enterprise implementation of your ArcGIS platform if you have Portal installed. Now that gives you the same protections as your organizational firewall. Again, you'll need to have that reference data like StreetMap Premium installed on premise. And now I'm actually excited to let you know that you'll also have the option to geocode in the cloud. And very soon you're going to hear from Dan at Spatialytics who's going to explain that option. For now, let me move on and explain the two strategies offered by the HIPAA Privacy Rule for de-identifying PHI. The first one is called Safe Harbor. The Safe Harbor method may not be terribly useful with regard to geographic information, but it is simple. Safe Harbor requires the removal of 18 types of identifiers from your data set to ensure that no one receiving it could establish the identity of an individual within that data set. So these are the 18 identifiers listed, all the way from names and dates to all kinds of identification numbers to biometrics and even full face photos. Now, importantly for this conversation is the listing of geography, which I'm going to get into in more detail shortly. But first, I wanted to offer another warning. Blindly following Safe Harbor is inadequate for de-identification of your data. So let's look at an example. Let's say you have a data set with emergency department visits for an entire state, and you diligently scrub out the 18 identifiers. You might think that the data set is de-identified. But what if the dataset has a person's occupation listed as one of the variables? And what if one of the ED visits was for someone with the job title of governor? The point is, every dataset is different and needs to be examined carefully to ensure that there aren't variables that could uniquely identify an individual. So even if you use Safe Harbor, you still need to think about the risk of re-identification. So let's talk a little more about how Safe Harbor considers geography. Basically, expressing data at a state level is okay. If you go smaller than a state, you have two options. You can use 3-digit zip codes or any geography that has more than 20,000 people. But consider this. While we do have some very large counties in the United States, more than 40% of counties are so small that they have fewer than 20,000 residents. In those cases, you could violate HIPAA by sharing county-level data. Now, I live in California, where 8 of our 58 counties have small populations, and I've listed them on the bottom of the slide. So you may wonder, does that mean that every time that you've seen a county-level map, that the privacy rule has been broken? Well, happily, the answer is no, not necessarily. And that's because we have the second de-identification method under HIPAA called expert determination. And this is where all of the flexibility of the law lies. The idea is that statistical principles can be applied in a way that makes the risk of re-identification very small. Now, please note that perfect anonymization is not required. It's very small risk. Also, it's worth knowing that the expert not only determines the appropriate method of de-identification, but they need to also assess the risk for that method and document it. So let's spend a few minutes talking about some common methods that people use to de-identify PHI under expert determination. The first method relies on the Numerator Rule. It can be helpful to know the heuristics or rules of thumb that some of our authoritative agencies use for their work. Now, the Numerator Rule is about suppressing small cells, and suppression is a type of statistical disclosure control where certain values are hidden to protect the sensitive information. Now, the CDC uses a numerator of less than 10 for their Wonder database. In other words, if there are fewer than 10 observations in a geographic area, then they would have to suppress the data in those areas to decrease risk. The National Environmental Public Health Tracking Network is a little bit more liberal and only suppresses cells with fewer than 6 observations. And CMS, the Centers for Medicare and Medicaid Services, uses a numerator of 11. Now, a review of many experts using the Numerator Rule showed a pretty wide range, going from 3 to about 40, but most actually fall between 10 and 15 observations. Well, what exactly does small cell suppression look like? So let's use the CMS rule of thumb for suppressing fewer than 11 observations. So that's really the same thing as saying less than or equal to 10. The map that you see on the left shows what the data would look like without masking or suppression. The light yellow areas are still identifiable as areas that have 10 or fewer cases. What you need to consider with suppression is complementary cells, so that anyone looking at the data couldn't mathematically identify areas that have the small numbers. So now take a look at the map on the right and focus on the legend. The description of the lightest orange class has been modified so that instead of saying 11 to 39 observations per area, like in the first map, it simply shows less than 40. Now that way, the map reader can't tell where the cutoff was for the suppressed or crosshatched areas. So again, when you're doing small cell suppression, be sure to think about complementary cells. Now, some organizations don't use a numerator rule heuristic. They use a denominator rule. In other words, their underlying population for an area must reach a certain level or threshold before the data can be shared. Here's what some of the experts use. The National Center for Health Statistics uses 250,000. The National Environmental Health Tracking Network uses 100,000. And the Maine Integrated Youth Health Survey uses 5,000 young people. In the box on the screen, I'm trying to show you why this is so important with an example of how the risk of re-identification can vary. So if we take the first scenario, it turns out that if you have in your data set a date of birth, the sex, and the 5-digit zip code for a person, you would actually be able to identify that person 50% of the time in the United States. But if you change the date of birth to a year of birth and you adjust the 5-digit zip code to a 3-digit zip code, you could only identify an individual 0.04% of the time. So denominators make a really big difference. The way we deal with the denominator rule is with aggregation techniques. You can aggregate on any or multiple variables in your data set, such as age, racial or ethnic categories, time periods like a month or year of diagnosis, and of course, geography. You can see an example of aggregation in the map where adjacent polygons were combined until the populations in the area met the desired standard. The issue is that we don't want to always aggregate at a 3-digit zip code because it's large and that boundary type may have no meaning for our data set. It doesn't really identify a community, and it may not align under a certain policy authority, and it's certainly a level that can mask disparities, decreasing the utility of an analysis. So we need better methods for aggregation than the 3-digit zip code. Now, Lucas of GIS Inc. is going to show you aggregation by manipulating latitude and longitude, or using different shapes like a fishnet grid, hexagons, or a tessellation of triangles. The point is, there are many ways to aggregate data at a smaller geographic level while still maintaining privacy. Another technique is a bit more complicated to perform. It's about perturbation, or randomly offsetting your individual point data in a way that obscures the actual address locations, but it preserves the overall spatial pattern. You can see the example in the map. We call this method geomasking, and this is another technique that Lucas has made really easy with MapMask. The big question, of course, is how far do you have to move a point to ensure that it's properly de-identified? Well, you can calculate a K-statistic, which is going to inform your decision making. And there is actually healthcare literature out there that offers suggested thresholds for K, and then basically your organization would decide what level is acceptable for them. Now, before I end, I wanted to share with you a few organizations that have really put some great thought into their processes. And the first is the Institute for Families in Society in South Carolina. They've created this decision tree that allows them to employ either the numerator rule or the denominator rule in their de-identification process. Similarly, California's Department of Healthcare Services has also created a decision tree. Their rules require adherence to the numerator and the denominator conditions. So if a data set doesn't meet those conditions, then they apply a scoring method that helps their users to aggregate data properly. So here's the scoring criteria that they use, which they borrowed from the Illinois Department of Public Health. Now, since there are endless possible variables that could be in health data sets, they focused on the most commonly used ones, like sex, age ranges, race, ethnicity, language spoken, geography, and dates. Now, the previous slide showed that their algorithm requires a score of 12 or less. So let's look at a scenario where you want to disaggregate your data by male and female. That gives you 1 point. You could use narrow age ranges of 1 to 2 years, and that's going to give you 7 points. And you might employ race groupings of white, Asian, and Black for another 3 points. So now we're at 11 total points. And that means that for geography, we would have to ensure that areas have at least 20,001 population to proceed. But let's say in a different scenario, we wanted to use smaller geographies. That's going to cost us 5 points. So then we might simply widen our age cohorts to 6 to 10 years. Basically, what this method does is it allows you to make trade-offs so that you can keep your most important variables as disaggregated as possible. Now, I want to let you know that for my remarks today, I borrowed heavily from a number of great resources, and I wanted to share them with you. Feel free to take a screenshot here so that you can dive into them yourself. They'll provide you with some detail that we just don't have time to cover in an hour. So now I'm going to turn it over to Dan Exley so that you can get the lowdown on how Spatialytics has developed a solution for HIPAA-compliant geocoding in the cloud. So Dan, I am going to pass the presentation over to you.
Thank you so much, Esty. Good afternoon or good morning to you, wherever you may be. My name is Dan Exley. As Esty said, I'm Chief Client Officer for Spatialytics. We're a company that provides innovative analytics solutions that are in the cloud that help organizations in a few industries, but healthcare is the one that's closest to my heart. I've spent over 20 years living and breathing healthcare, most of that healthcare IT, and a lot of that time focused on modern big data analytics for healthcare provider organizations. I joined Spatialytics last year because of how much value I saw over the previous few years that spatial analytics can bring to healthcare organizations of all stripes. So it's been really exciting to bring forward a collection of solutions, including our healthcare GeoCoder, that's a HIPAA compliant solution in the cloud to help organizations large and small jumpstart their spatial analytics activities. So we're a company that has a global presence, headquartered here in Chicago, Illinois. We work, as I said, with a number of industries, and today we'll look at a couple of things that we're doing in healthcare. The portfolio that we've brought together starts with our geocoding service. We have some standard aggregators that we're releasing in coming months for a range of standard systems that are out there in the environment. Starting with the major EMRs with Epic first and likely Cerner and others coming close on its heels. This enables sort of turnkey geocoding for major system sources. But we have the ability to connect through a variety of methods, which I'll share with you in a moment, to help an organization regardless of where their data resides. And then we build applications that help with clinical decision making and business planning and other operational decision making. While our GeoCoder is a cloud-based solution, for our other solutions, we offer hybrid and on-prem deployments as necessary. Esty did a great job of overviewing the requirements of HIPAA, the dimensions of what data is construed as HIPAA. We've built our health platform with HIPAA compliance at its core. And as a company, we're in the process of pursuing our high trust certification as a codified, structured way to demonstrate our compliance with HIPAA and other standards. There are a lot of state regulations now that are coming to bear that impact our compliance with health data. And we are absolutely tracking with all of those and intend to be right abreast of those as your state may require additional requirements beyond that which the HIPAA guidelines require. So from the start, we've built a system which of course encrypts data at rest, that encrypts during analysis, encrypts it in flight. We do execute those business associate agreements up and down the chain. We're hosted in the Microsoft Azure cloud environment. We have an agreement with them, so your covered entity data passes through our environment and is processed in their environment. There's a contractual relationship up and down the chain. We also have something called inbuilt data segmentation, and I'll tell a little bit more of that in a minute, but that means that even when it's in our environment, we're segmenting out PHI from other data so that we're really hardening and partitioning that data within our environment so that you have the least exposure possible. What that means to us when an analyst submits data to our service for geocoding, it's encrypted end-to-end. When it lands in our environment, we actually look at the data that's been submitted for geocoding, parse apart the components of the input that are required for the geocoding, such as the street address and the zip code, separate those from the other data you may have submitted, and only process then the geocoding required data, link it back up, and then lastly do the geocode and then send it back to the analyst in an encrypted format. I say we support organizations large and small. An example of this is that we built from scratch for the GeoCoder 3 different ways for an organization to use our cloud-based HIPAA compliant geocoding service. The easiest to understand is our web portal. An analyst or a practice administrator or a physician can just log in quickly to the portal, upload a file, choose how to map it, so you don't even have to force your source data into our format. You can tell our system which columns have the address information. Click run and get your results back. Conversely, we have organizations that are using ArcGIS Desktop or Pro, for example, that might want to just have a plugin within their native tool. And then lastly, for those individuals or organizations that have large data warehouse environments, for example, where the data warehouse team leverages our tool, calls out with a machine code, that API code, and either does batch geocoding or does a nightly catch-up. Or other cases, we have organizations that are looking to embed our geocoding as a part of some web app that they're building, and they're doing call by call. For example, when a patient's looking up some information that has to do with a resource for healthcare, and they want to know where's the closest one to them, their web application is calling out to our solution, and there's a geocode that's happening there, machine to machine. So very large organizations and very small individual researcher physicians are equally receiving value from the Spatialytics geocoding tool. An easy to understand look at this on the web portal version for a user that wants to go and do some geocoding manually. Just saying, hey, I've got a file here. Somebody just sent me a list of all the patients, somebody in the billing department, for example, sent me all of the patients that we saw within the last month in our physician practice. Here at this location, I've got them a spreadsheet that has a list of all of the patients grouped by payer and plan. It tells me which physician they're seeing and which day that they came in to be seen. Of course, that's a file that's full of protected health information. But if I wanted to see that on a map, I don't have an easy way of doing that natively without getting it geocoded. So I might log into our portal, and these are some of the sort of the admin screens where you could see here I can set it up so that user 1 could have access or user 2, but as an end user, I might say, just really quickly, let me go geocode. Let me choose my file, pick a file from my desktop, a spreadsheet or a flat file, tell our system which columns contain the street, the city, the state, and the zip code information. For example, one other thing that's nice is if your systems, if you got a file that has address in a single column, one field that has all of those comma delimited, for example, we can handle that as well. Upload the file, it'll check it, make sure that you've got the entitlements that needed to do it, and then run it and process it. When it's done, your file that you submitted now has new columns added and appended to the end of it. And it's a little bit of an eye chart there. So this is on the left, some information about the patients that came to your clinic, which doctors and payers and plan they saw. Of course, this is all fake data. But then off to the right, the data that our platform has added that you can then analyze in your ArcGIS desktop tool, for example, or some other business intelligence tool that's capable of analyzing geocoded data, but you just didn't have it geocoded previously. The specifics of what we've added then are, of course, longitude and latitude, but we also have information that SD alluded to a few minutes ago. Accuracy information, perhaps the data that was submitted, the data that you got from your billing department, wasn't precise enough for a rooftop level geocoding. Perhaps we could only get as precise as a zip code level or a city level. Sometimes we find that there is a 250 West Main Street and a 250 East Main Street in Anchorage, Alaska. So if the system didn't get anything that tells you, but that it tells it that it was west or east, you'd return back a lower granularity. It would say, well, I know this is in Anchorage, but I can't tell you if it's west or east, and that accuracy level would be lower. We also append standardized address information where we needed to do some cleanup, for example, so that if you had Main Street ST, Main Street STREET, Main Street ST period, we return back a normalized value for that so that you have an easier task doing that analytics when you get to the other side. So some cleanup and data quality enrichment work is a part of the result set too. So again, in summary, this solution provides an easy way through a variety of methods for an organization to submit data for geocoding, to have it processed in a HIPAA compliant way, adding coordinates and data quality enrichment for that submitted data, and to return the results back in the way that suits you best. So if you need it in a flat file, if you need it back on that spreadsheet so you can send it off to somebody else, if you need it in a machine encoded way so that your web app developers can consume that and use it as another part of a process that you've built, all of those are supported by this simple solution. This is sold as a subscription. We have small, medium, and large t-shirt sizes, if you will, for the size of the subscription. Very modestly priced. For us, it's very important that organizations take this first step to be able to start geocoding their data so that they can go do more with it. And what follows then is the exciting part, where we really get to then start to have a better sense for how you know your patients and know your community. And that's where the other solutions in our portfolio bring value to bear. And we could talk about those in another session, but the things that we do really help with an understanding of health data, with business planning, to help connect patients with providers, to understand how the market is changing around your organization, to figure out how do you build out a better network of providers or a better physical network of care venues for your patients. So those are the things that you're able to do with your tools or can do with our tools as well. We believe that geocoding and spatial analytics in general helps healthcare organizations do more for their communities, go faster as an organization with decision making, and be better as organizations and partners to enrich the communities that they reside in. So it's a quick walk through the HIPAA compliant geocoding approach from Spatialytics. And I'm going to hand the microphone over to my colleague here. And Lucas will now talk about some of their MapMask solutions.
Thank you, Dan. Appreciate being here today. I want to go ahead and show you all what we've been doing at GIS Inc. GIS Inc.'s been working in the GIS field for 28 years now, and we're working on a product that is helping people be able to mask their data. As Esty said earlier, MapMask is made to either statistically obfuscate your data or randomly obfuscate it, or to aggregate it into certain bins, so that way you can maybe release the data to another agency within the government, another department within the hospital. You can release it to researchers, and you're anonymizing the data enough that you're HIPAA compliant without aggregating it to the point that it has no use. Keep in mind, MapMask is the calculator. It's not an easy button to HIPAA compliance. Depending on your data set, your location, whatever you are trying to do, other methods may need to be applied. So please keep that in mind as you use MapMask that you still got to follow your HIPAA compliance procedures. It is not an easy button. Okay, so we approach this from what are really the main attacks? How is somebody going to try to de-anonymize data? And one of the main attacks is the journalist attack. And this is very popular with tabular data. People go in and try to match up, okay, well, I got this data set and this data set, and I'm going in to try to find other people. The k-anonymity method, especially with geography, has shown to actually be overkill for protecting against the journalist attack. If you pull out the attribute data, it's normally not a spatial problem to get the journalist attack. There are some situations with very discrete diseases and very rural areas you might run into an issue. But like I said, it's a case-by-case basis. Where k-anonymity really comes in handy, and we're going to show an example of this, is the prosecutor attack. And this is where somebody already knows a little bit about that data set. And in the example we're going to talk about is, we're going to use me for example. Let's say I know that Lucas had a heart attack. I know where he lives, and this is the data set from heart attacks from last year. So I'm able to go into this data set and try to de-anonymize him and maybe find other information in the process. What k-anonymity does, the way we're applying it spatially, is it's going to randomly move the data around to where you can't necessarily know exactly where Lucas is, but we're going to move it enough that other records could be confused for him. And this concept has been around for a while. If you go to mapmask.com to our FAQ section, you can see where we've linked to other studies that have used this to basically confuse the data but preserve the patterns. So if you notice, 6 points in this moved data, and we're going to look at an example of this here in a second, have ended up closer to the original location than the final point. This confuses the data to the point where somebody who already knows a little bit about the data set won't be able to go in and find it necessarily. Keep in mind, this is somebody who already knows something about the data set or already knows about a record. This isn't just a random person looking at the data set and trying to find something. So keep that in mind. Like I said, we have more studies at mapmask.com if you actually want to follow those links in the FAQ section to go into great detail on how this works. Now, in my demo, I'll go over this quickly, but you're going to hear a lot of people say you need to anonymize k-value to 5. And what k-value is kind of the number of records that it can be confused with. Keep in mind, when you have a data set, you're moving points around, it ends up being a distribution, not necessarily everything's going to have a k-value of 5. Some will be much more, some will be less. The number people like to throw around is k equals 5, because what that does is, if you look on this chart with the black line, you have very few to no records in that 0 to 1 range of a k value. And that would be key, because if something has a k-value of 0, it can be pretty quickly re-identified. All right, some use cases. Most of this audience is into healthcare, but I mean, it could go into research, software testing, drive time analysis, quality improvement measures, and we also work with industries that aren't in healthcare. Banking, confidential clients, commercial clients wanting to release client data to marketing. So that way marketing can do something, but they don't want this marketing company to know exactly where their clients are. So keep that in mind. This isn't just for PHI, but today we're talking about PHI. Okay, I'm going to switch over real quick to a video. And can you all see the video? Can somebody confirm that for me?
Yes, I can see it.
Okay, thank you. All right, so MapMask is just an extension of ArcGIS Pro. It appears on their ribbon after you install it, and it opens up as a dockable window. Now, you'll want to know what data you're working with. In this case, we're going to work with homeless data in the Austin area. And let's take a look at a heat map to show how the original data. So you have a cluster in the bottom, and you got kind of 2 bands at the top. And after we anonymize our data, we want to see that same general pattern. Our goal is to anonymize it, but not lose its actual value. So what we do is we come over to MapMask, and we're going to pick our input features, our homeless layer, and we're going to draw a masking area around the data we want to mask. In this case, we're going to pick the whole data set. In larger data sets, you may not want to do that. So it picks the data, and then we're going to look at our masking algorithm. We talked about k-mean neighbor, k-value. A lot of people say 5, 7, 8 is a good number. We're going to be conservative today and use 10, and we want to target a specific average between 11 and 15. And so you can see it jumbled up the data pretty good. In the areas that are more disparate, you see it having to move it a lot farther. In areas that are clustered, that's much tighter. And then in the north, it's trying to preserve those patterns by moving things all different directions. You can have the basic summary statistics over here to the right. And if you don't like them, you can run it again. It'll pick a different random seed, pick different locations, and you're going to get slightly different answers. And it looks like in this case, we have one record with a minimum k-anonymity score of 0. So that's pretty good. And I'm going to show you how to look at that individual record here in a second. But first, we had people complaining that things ended up in water, and they didn't like that. So we created the ability to use an exclusion layer. And so if you turn the exclusion layer on, this is going to say, I don't want these records to end up in these water layers. Now, we're not going to run this again. It takes about a minute to run that when you use an exclusion layer. But I did run it earlier, and we're going to take a look at that. Now, let's say we ran our data, and this is our final data set. This data set's been anonymized, and we want to look at it and go, okay, is it anonymized enough? What are some of the statistics? Now, in the attribute table for this data, we strip out all other columns. We leave you the ability to go back with the original point ID to tie it back in if you want, but we strip it out as part of our export. If you go to k-anonymity score and look at the distribution in the statistics, you take it out to the number of bins for it, and you see down there is 1 or 2 records in that very low area. I did a pretty good job of having k-anonymity of 5, 6, 7, 8, and 9, and some records going all the way up to 60 or so. But you want to take a look at those records that are in that 0 to 1 range. So in this case, we have a record that's 0. It moved about 400 meters. In this case, I went back and looked at it. That was a little bit of a cluster that the other points all moved away from it. So you may choose to delete this point and not include it in a release data set. You may want to run the analysis again, but you probably want to go in and check those. Let's go ahead now and see if this anonymized set matches well with our original, and see if we still have those 2 clustered bands in the top and that cluster in the middle. So if you look at the heat map, you still have a good cluster in the middle. Those bands at the top have been a little distorted, but depending on what you're doing with this, what type of community you're looking at, how deep the analysis needs to be, that may be acceptable, it may not. Keeping in mind, we used a k-value of 10 with an 11 to 15 average, and a lot of people who do this will tell you that's probably a little on the conservative side. Let's go back and now look at some of the other features we have. So let's pick our data set again. Now we're going to look at just rounding some coordinates, and basically this is a way to do bins without losing your point data. So we're going to pick coordinate rounding, and it's based on the number of decimal places and degrees for your map. So basically, in using latlong, it is going to put all these points in one spot and create a grid. For really large data sets across large geographies, this can become very handy. But depending on the number of decimal places you pick is how much it's going to move it. So if you notice, it basically creates a grid, and those are stacked points on top of one another. Now, it allows you then to see your general distribution. But if you also go up here and look at it, I ran this earlier, this is the pattern you get when you put a heat map on it, and you still see that general pattern of 2 bands in the top with a strong band in the middle. So as you can see, that has allowed you to maintain your patterns and basically bend your data to more of a grid shape. One other we're going to show here, and this is more just allowing you to do random ossification. And based on your lat long, you're going to offset it so many degrees in so many different directions. And we're just going to randomly pick those based on the range you pick. So after we process this, you can see these points just went in all different directions based on the distance we gave, based on a random picking of the distance and the direction. And if we want to change this, say that moved it too much for whatever you wanted to do or to get some releasability, you could also process it again, and it's going to move it again. Keep in mind, unlike the K statistic, it's not trying to preserve clustering. It's just going through each point and randomly moving it. So it's just a complete randomization of your data, and it would take a little bit deeper analysis to know, is it random enough or not. But it can also depend on what kind of data it is, the sensitivity of it, and the likelihood that somebody is going to try to attack this data. Okay, let's switch over now to more of the traditional bin styles. And what we're going to look at is doing some triangle bins. So it was brought to our attention that this is a common method people like to use. And so we just put this in here that allows you to then just pick what shape you want, triangles, squares, or hexagons. And in this case, we're going to do triangles for 2 square miles. So that way each triangle has 2 square miles of area in it. And for now, we're going to keep the 0 bin so you can see what that looks like. And so we're going to generate that. And this is what the data then does. It puts everything in that data set in a bin. Now, if we want to go ahead and change the symbology of that colors real quick, Arc Pro is very handy for doing that. And then it'll just graduate the colors and you can take a look at it. Now, say you showed this to your boss and he said, I like hexagons better and I don't like all those zeros. Well, you just remove the previous, get rid of the bins, switch it to hexagons, and you run it again. And it will run the analysis again, saves it out to your geo database in Arc Pro, and you can go up and change the colors again, and you have a similar pattern that shows here. So it allows you to see how the data is actually distributed, and you can make these as big as small as you need. And also, once this gets approved, if you want to release it to another agency or to somebody, even the public, you could actually quickly do that in the sharing features with the web map in Arc Pro. It'll allow you in that share tab to push it to an enterprise environment so that way it can quickly be shared with other entities, other agencies, or even the public. So that is built in as part of Arc Pro. That's all I have at this point. I'm going to switch back to the PowerPoint. Okay. Real quick, go to mapmask.com. All this information is there. If you have questions, want to reach out to my team, just go to mapmask.com. If you need it in the cloud or in the server, let us know. We do have the capability to do that. But we're more than willing to talk and figure out what you need to get this going for your organization. With that, I will hand it back over to Esty and Natalie.
Thanks, Lucas. Natalie, I think you're going to help us moderate questions.
Yes, I am. So one thing first, I just want to make sure everybody knows, yes, we will be sending out this recording. So it has been recorded and it will go out next week. If you don't get one, please just email me. You would be able to get it through the invitation you got in your email. So, okay, Esty, a question I received for you. I use ArcGIS Pro. Can't I geocode addresses on my desktop? That will give me the chance to cover different Esri architecture scenarios for geocoding.
Yes, absolutely. So you can use ArcGIS Pro, but if you're going to do it on your desktop, you need to have that reference data, as I mentioned, actually sitting on your desktop as well. You don't want to use, some people might think that they're using ArcGIS Pro and then they go and use their ArcGIS Online through that interface and geocode that way, and that would be a potential breach. So You can use Pro. You can also use anything within your enterprise if you turn on Portal. Remember I mentioned that. So if you have a server environment with ArcGIS Enterprise, again, you have to have that reference data on premises. So if you're thinking that you want to do your geocoding in the cloud, that's when you want to call Dan from Spatialytics.
Thanks. Okay, so I actually have a question for you, Dan. What is the average processing time for geocoding through the API? Just a rough ballpark of max records per day, for example.
We scale to over 1 million records per hour if the need is there, and that's not something that you have to specify on submit. So it processes very quickly. We have an elastic compute infrastructure. So if an organization has a bulk need one day and just a tiny need the next day, they get the same responsiveness and don't have to arrange for anything otherwise with us.
Great, thank you. Okay, so Lucas, question, where can I find other studies that have used k-anonymity with health data?
Yeah, we've compiled a list of them in our FAQ section on mapmask.com. And those will actually, if you look in the bibliography of those, or if you go to National Institutes of Health and just search k-anonymity and privacy data, there are a lot of studies out there. If you don't find what you're looking for, just email us at mapmask@gisinc.com, and one of our team members will try to help you find something that will make whoever's asking you the question about HIPAA compliance satisfied that k-anonymity will work for you.
Okay, great. Now I have a question for any of the three of you that you'd like to answer. If we receive a marketing list of addresses and we remove the patient addresses from the list, is geocoding that list via non-HIPAA compliant geocoders a HIPAA concern?
So if you could just read it one more time, make sure we understand it.
So if we receive a marketing list of addresses and we remove patient addresses from the list, is geocoding that list via non-HIPAA compliant geocoders a HIPAA concern?
So it sounds to me, and guys, please feel free to jump in as well, but it sounds to me if it's a marketing list that they've received, then the fact that patients are in there is kind of happenstance. I mean, we all get marketed to, and we might also be patients. So it's not protected health information. However, if that list, if you're a health system and you're using, for example, your client billing information to market specific services to those patients, then you would need to separate the address from the health information. Now, I will tell you that people will disagree on this point as to whether or not that information is PHI. So technically, it's possible, for example, that somebody could identify that that's being geocoded through an IP address that belongs to a health system, and so they know that even though there's only address data in there, that they may relate to patients in some way. But you know, I showed the graphic of PHI as identifier information plus health information. When you break them apart, technically, it's not considered PHI. I would just be cautious because, like I said, some people disagree and would not perform that function.
Yeah, Steve, this is Dan. I couldn't have said it better myself that, you know, that always check with your compliance officer or your privacy officer and see how they read on this question. An organization that only does one type of clinical care provision, for example, an oncology clinic, or some other subspecialist, anything that they do infers a relationship with that address and potentially household members of that address. So an organization may take a very conservative approach. Another organization with sort of a broad mission, with a very generic citywide or statewide use case might take a different approach. The devil's in the details, and always check with your internal guidance.
Great. Okay, so another question for all of you, actually. Any suggestions for Canada customers? Here we deal with PHIA. I'm looking for similar tools, processes for Canada-specific data.
Well, the Spatialytics HIPAA compliant cloud-based geocoding services actually sits on top of a global data set. We absolutely understand that HIPAA really is a US regulation only, but every other country cares about protecting their information. So the same infrastructure and design principles are all in play. If you have a country level requirement for a specific Azure region to host our environment, we absolutely can provide that. But the base maps and the lookup functions for all of the countries around the globe are available within that. That's helpful for other countries to use it, but also we have domestic organizations that are doing global health outreach or have a clinic in Dubai, for example, and they might want to have international geocoding functions, and we support that natively.
Lucas, you want to answer that for MapMask?
Yes. Yes. So as of right now, we haven't talked to anybody from Canada. I'd be interested to speak with whoever asked the question privately. But what we're trying to do with MapMask is leave it generic to where it does certain statistical or geospatial processes. And in the future, we're going to add population data, so you can do numerator, denominator rules. It really depends on what rules you have to follow in order to anonymize or release data. We're trying to leave ours generic enough that if one method is allowed and the other isn't, you could still use that method. So we're not trying to target even healthcare specifically. We're just trying to target anonymizing data generally. So that way, anybody who has a privacy concern with data can then use our tool in some way. But I'd definitely be interested. Reach out to me privately to discuss some of the rules in Canada to see if we can't help you out.
Yeah, I think you two answered it perfectly. My advice really is well aligned, which is, talk to us and figure out what are the differences between HIPAA and your regulations, and then it's just a matter of tuning the different tools to your needs, but the procedures should all be very much the same. I think it's just a matter of tuning. Maybe I can ask Dan and Lucas to maybe say one more word about what you'd like people to do from here, if they would still have an interest, and then we can close out the webinar. So Dan, how about if you go next?
Sure, thanks. Please take a visit to spatialytics.com. You can see our health product page. When you receive the content deck email that, as Esri mentioned earlier, all of this content and references, I'll be there. My contact information is there. Be happy to follow up with any of you directly about how we could help with healthcare geocoding or any other healthcare spatial analytics use cases that your organization might be pursuing.
Thank you. Lucas.
Yeah, if anybody is interested, please go to mapmask.com or gisinc.com, or you can reach out to me individually. And we would just love to hear from you. We would love to see if the tool would work for you, if you have any feedback for it. And by all means, if the tool doesn't do something you want, we're releasing a new version about every quarter. So let us know what you want, and we'll try to accommodate it. Just thank you all for paying attention, and really look forward to hearing from you all.
Thanks, Lucas, and thank you all for joining us today. I think this is such an important topic, and I think you can hear from all of us. We really just want to be there to help you overcome this challenge, because we know it's one of the major barriers to really getting the value out of your geographic information that you want. And I think the great news is there are solutions for you. So, so we're happy to help. You have our contact information. Call us, email us. We just want to help you get to your mission a little faster, a little easier, and with good information. And please, I know you've been seeing it for a few minutes, but we have several meetups coming up in the future. There is a link there so that you can see them and put them on your calendar. Lots of great information to share. So I hope you've enjoyed the time, and thanks again for joining us. Have a great afternoon.